Welcome aboard, engineer. You've just been promoted to lead engineer for Neoterra, humanity's very first city on Mars. Your job? To keep this entire colony running. And that means you have got to master the numbers that are, quite literally, the difference between life and death out here on the red planet.
Okay, your very first alert of the day is a big one: oxygen levels. Every single morning, you're checking this balance. Now, when our hydroponic gardens produce 4.2% more oxygen, that's a positive. At the same time, the backup tanks deplete by exactly 4.2%, a negative. It's this perfect, super high stakes balancing act where positive and negative values aren't just numbers on a screen, they are the line between breathing easy and, well, catastrophic failure.
So yeah, congratulations on the promotion, lead engineer. Every single value you see flash across these screens, from power drain to water rations, is absolutely mission critical. So your first task is to get really familiar with the numbers that keep this whole colony from falling apart. Out here in deep space, every value matters. We've actually nicknamed the numbers you'll see every day the Rationals Squad. You've got your whole numbers, you've got decimals, fractions, mixed numbers, the whole gang's here. Now, they all look different, sure, but they share one crucial thing in common. And here is the secret handshake. A rational number is simply any number that can be written as a fraction. Just think of that A over B format as a universal docking port. An integer, like 5? Easy. That's just 5 over 1. A decimal like negative 2.2? Well, that's just negative 22 over 10. See? They all dock perfectly. Now, if a number can't be written as a fraction, well, those are irrational, and we'll save those mysterious aliens for another day. All right, let's move on to challenge 2. In the total vacuum of space, direction is absolutely everything. But you also have to watch out for values that are in disguise, hiding right in plain sight. So let's talk about the concept of opposites. Check this out. If ship A travels positive 1.5 light minutes north from our station, and ship B travels negative 1.5 light minutes south, they've actually gone the exact same distance, right? They're just in opposite directions from our starting point, our point 0. And this is what happens when you combine those opposites. If you add a positive 1.5 and a negative 1.5, you get right back to where you started, 0. It's like the ultimate cosmic undo button. It just resets your position completely.
But you gotta be careful, engineer. Some numbers are, well, they're shapeshifters. We have 3 cargo crates going in, and each one has a totally different looking code on its manifest. Now, at first glance, you might think, okay, 3 completely different values. But are they really?
Surprise, they all simplify down to negative 4. It doesn't matter if the negative sign is up top with the numerator, on the bottom with the denominator, or just sitting outside the whole fraction. The final value is exactly the same. In our database, we call this value parity. Negative 8 divided by 2 is negative 4. 12 divided by negative 3 is negative 4. They're all the same value, just, wearing a different uniform. Okay, engineer, this is it. Deep breaths. This is your most critical task of the day. We have 5 vital supply pods approaching Neoterra, but their landing coordinates are a complete and total chaotic mess. You have to get them in the correct order before they hit the atmosphere. No pressure. Just look at this data stream. We've got negative decimals, positive fractions, repeating decimals. It's just impossible to compare them like this. We need a system. We need a protocol to sort these from the smallest value all the way to the largest. And here it is, your mission protocol for ordering. Step 1, translate everything into a common language. For us, that's decimals. It's our universal translator. Step 2, visualize them on a number line. Remember, the further to the right a number is, the warmer or greater its value. And step 3, and this one is so important, you have to avoid the negative trap. Okay, this is where our brains can seriously trick us. The number negative 2.1 looks bigger than negative 0.833, right? Because the digit 2 is bigger than 0. But with negatives, the opposite is true. You got to think of it like temperature. Negative 2.1 is colder. It's further away from 0, which actually makes it the lesser value. The number that's closer to 0 is always the warmer or greater value. And the exact same idea applies to fractions. Let's say you're comparing negative 2/5 and negative 1/3. First, find a common denominator, something like 15. That gives you negative 6/15 versus negative 5/15. Now, which one is closer to 0? It's negative 5, right? So negative 1/3 is actually the greater or warmer value.
And mission accomplished, engineer. The pods have all landed safely, and it's all because you understood the true value and the true order of those numbers. You navigated the opposites, you saw right through the disguises, and you totally avoided the negative trap. Great work. You know, it doesn't matter if you're managing a colony on Mars or just tackling your math homework. It all comes down to knowing exactly where your numbers stand. Once you can accurately compare them and put them in order, the universe and, yeah, your assignments, they start to make a whole lot more sense.
And that brings us to our final question for you. If you were sent to our Mars colony, what's the one thing from Earth you would want positive 100% more of, and what's the one thing you'd want negative 100% of, meaning you want it completely gone forever? For me, I'm voting for more pizza and 0 mosquitoes. Definitely. Let me know what you think in the comments below.
Go ahead and like if you're ready for liftoff, and make sure to subscribe to join the crew for our next mission. We'll see you in orbit.